In this example, we have the flight of a rocket at the Symphony of Fire is described by this function, where h is the height of the rocket and t is time. And since the rocket was fired, what is the height reached by the rocket? Max height reached by the rocket. So here's the equation. So that's actually asking vertex. Okay, so we have to look for the vertex. How many seconds after it was fired does the rocket reach the height? So we want the vertex. So for A here, we want, therefore, the vertex is going to be, so read it off of here, 5, 124. What does the 5 represent? 5 is always going to represent the variable it's with, so that's t. So that's t. And this 124 will always represent the overall. So this would be height. So that's the time and that's the height. So this one will always represent the t that it's with. So this value here, the first value will always be whatever variable it's with, t, x, whatever it is. So 5. And then this outside 124 always represents this outside variable, which is the height. So then you would say, therefore, the max height is 124 meters when, so it's 5 seconds. There you go, 5 and t is in time in seconds. So that's it. For B, it says, how high was the rocket above the lake when it was fired? So when it was fired, that means, you want to look at this, when it was fired means at the beginning. So t equals 0. So you have to know these words. So when it was fired is at the beginning, so when t equals 0. So you're going to sub in, so let t equal 0, and you're going to sub that into your equation. So h equals negative 4.9, t minus 5 squared plus 124. So this would be t equals 0, so this would be negative 4.9, and we're going to sub in 0 minus 5 squared plus 124. This you keep going, and then 0 minus 5 squared, this is going to get me 25 plus 124, and then we can keep working this out. So if you want at this point, it would be okay to sub this into your calculator. Negative 4.9 times 25 equals negative 122.5. So negative 122.5 plus 124. It's okay if you just sub that right in and went plus 124. And that would get me 1.5. So therefore, when fired, it was 1.5 meters above lake. You don't need a big sentence, but just enough so you can be clear. Okay, and then in my next example here, the parabolic flight of an aircraft used to simulate weightlessness. So what they do is they put you in an aircraft and they would drop you so that, you know, that feeling of your tummy and you're kind of floating for a minute, you're kind of hopping up. They would do that on an airplane, So they keep going up and down, up and down. It can be modeled by a quadratic equation where h is the altitude of the aircraft in meters and t is the time since weightlessness was achieved. So basically they're taking the plane and they're going up and then dropping, up and then dropping. So that is making a nice parabola shape when they do that. So h is the altitude of the aircraft in meters, t is time in seconds. Since weightlessness was achieved, find the maximum altitude reached by the aircraft. So the maximum altitude is going to be the vertex, of course. So we know that this is vertex. So here, maximum altitude, so let's highlight those words. So it says maximum altitude, what they're actually asking you to find is vertex. This word here. So what is the vertex? Okay. the number of seconds it takes to reach the maximum, we'll get that in a bit, and the altitude when it's first achieved. So let's just start with number 1. So A here, we want to find the vertex. So I've got the equation, negative 10 t squared plus 300t plus 9750. So the other question we did, there was no extra t. Here I have 2 t's. So you have to grab both of them, and you're going to common factor out the negative 10. And you're going to go 10 t squared minus 30t. So divide the t out from both. And we have this guy left over on the side, 9750. So now we're going to do the completing of the square. So again, you don't have to show this, but what we're doing here is half the middle, so 30 divided by 2, squared. 15 squared is 225. Again, you can do that on the side. Keep the rest of these guys, the rest of them just hanging around. So we're going to go t squared minus 30t, and this is going to be plus 225 minus 225. Like that, and we're going to get this blue number here sits on the side waiting to be used. Then we're going to cover this up, and we're only going to factor this part here. So we're going to go negative 10, and two numbers that multiply to 225 and add to negative 30 is negative 15. And then to get rid of this dude, you got to go here times here and pop it out. So negative 10 times negative 225 is positive 2250. And you bring the plus 9750 here. So then that's it. We just have to clean this guy up. So this will be negative 10. This is t minus 15 squared. Bring those two together. So 2250 plus 9750. And we're going to get plus 12,000. Whew, that's it. So once we've completed the square, you pretty much can answer everything, I bet you anything. So for A, it says, what's the maximum altitude? Oh, right. And so I do, therefore, vertex is 15, the opposite, 12,000. You have to, for all your vertex, you have to put the bracket, and you've got to tell what the variable of each one is. So if 15 is with the t, this is t. And the 12,000 is on the outside, which is the h over here, so this is h. Okay, and it always works that way. So what's the maximum altitude? So that's not time, that's altitude. So you're going to say, therefore, max altitude is 12,000, is it meters? Meters. Okay, and when the number of seconds an aircraft takes to reach the maximum altitude after weightlessness is achieved. So the number of seconds, so A is the maximum altitude is this. For B, it says, when does it occur? So max occurs at 15 seconds. So we're good for 15 seconds. For C, it says the altitude when weightlessness is first achieved. So the maximum weightlessness simulate. So 0. So 0. So they're asking first achieved. So they're asking this question when it was first achieved. When we use this equation is where h is the altitude since weightlessness was achieved. So that's at the beginning of it. So what they're asking, so first achieved would be when t equals 0. So when t equals 0, find h, the altitude. So let's take that guy and we're going to sub it in. So t equals 0. Let's grab our equation. We can grab the original one. T squared plus 300t plus 9750, and we're just subbing in 0 wherever we see the t. So this will be negative 10, 0 squared, 300, 0, plus 9750. That goes to 0, that goes to 0. And so we're going to get 9750. So therefore, the altitude is 9,750 meters. That's it. We had to find h when t equals 0. So that, and the reason why you said that, you might go, I don't know, when it was first achieved. And when you read the words, when h is the altitude since weightlessness was achieved. When it first happened would be 0, the starting point of the graph, first achieved. Okay, for D it says the number of seconds the simulation of weightlessness lasts if weightlessness is lost since the altitude, at the same altitude as it was achieved. So same means that you're checking when the altitude is 9750. And we're going to find the time for that. So I'm not sure if we can answer this question. Oh, yes. Okay, we can. So then for D, we're saying find T when H equals 9750. So this, we're going to grab my formula again. And we're going to sub in this H into the H. So that would get 9750. Okay, and it's going to work out. Here we go. Oops, 9750. Then if I bring everything over to one side, I'm going to get 10t squared minus 300t. So minus 300t. And when 9750 comes over here, 9750 minus 9750, you get 0. Now, this part, we've done a bit of solving and with factoring. So if I common factor out 10t, I'm left with t minus 30. Now, we looked at this before with factoring and then solving. So 10t equals 0 and t minus 30 equals 0. So then divide both sides by 10. So t equals 0 and t equals, bring the 30 over, is 30. So that means it's symmetrical. And again, we haven't done a lot about this, but this is symmetrical. So what this is saying is that it's symmetrical. Oops, sorry, symmetrical. And there's some symmetry. So if we have over here on our graph, this is 0. If we know that it reaches a height of 9750 when it is, the maximum height is 15 and 12,000, so something like this. Find height when t equals 0, so we go like this, which is 9750, and it should be symmetrical, so we're looking here. So we want to know how far away is this here, so we can do it this way. So we want to make sure it comes back down here. So how far away is the vertex? The vertex is at 30. Right, sorry, the vertex is at 15. Right, I read the wrong number. Is at 15. So this is another way to do it. So 15, like this, 15. So then we know that it's 15 this way and 15 this way. So this must be at 30. So you don't have to show this. This is only if you understand how to solve it. Okay, so then this part here, I'm just going to put it into a bubble. Okay, and we're not comfortable with solving it, but we will get to this later on. With the way I want you to do D, so I showed you this because if you know the algebra, you're welcome to show it this way. For us, for most of us, we're looking at the symmetry of the graph. So we're going to say the vertex is at 15, 12,000. We know it starts at 9750. We're asking the same altitude, so this word same altitude means that we wanted it to be symmetrical. So if this is at 15, it's another 15. So therefore, you would just show your little sketch and say, therefore, it is the number of seconds the simulation of weightlessness lasts. So therefore, it lasts 30 seconds. Okay, and that's it. So they want you to do the vertex 15 to the maximum and see how long before you drop again. Okay, so it sounds like a difficult question. This I showed you only if you understand the algebra. If you don't understand the algebra, then you're looking at the graph. If the vertex is at 15, it takes another 15 to be symmetrical with these guys here. So it must be 30. Okay, and that is a bit of a tricky kind of thinking question.